Now we continue with the correlation topic. But before that, in the last video, there was a mistake. That means 35 into 35, 1225. Instead of that, it is mistakenly written here as 1235. 35 to 35, 1225. It is written here as 1235. It's a mistake. Please correct that. Okay. Other answers are correct, but this is to be corrected. Sorry for that. And now we continue with the correlation. See, if the question in your correlation question appears like this, x and y variables are given in your question, and you have to use this formula. This formula we already studied in your last video. We have to use this formula to find a correlation. If the question appears like this, x variables and y variables are given, then we can use this formula. Okay. Sometimes the question may be different. It looks like this. Here is a question. Look at this. If the covariance between x and y is 488 and variance of x and y are 824 and 325 respectively, find R. R means Karl Pearson's coefficient of correlation. This is also a question to find a correlation. Okay, here x variables and y variables are not given, but some other details are given in your question. If question appears like this, we cannot use the first formula. In such a case, we have to use another formula which is here. This is also to find out Karl Pearson's coefficient of correlation. R is equal to, the formula is covariance between x and y whole divided by sigma x into sigma y. This symbol of sigma means standard deviation. Standard deviation of x into standard deviation of y. So this is the formula that is to be used when the question looks like this. Okay. So covariance between x and y will be given in your question. This sigma x means standard deviation of x. Sigma x means standard deviation of x, and this sigma y indicates standard deviation of y. Okay. Once more, come to this question. The question looks like this. If the covariance between x and y is 488 and variance of x and y are 824 and 325 respectively, find R. Find Karl Pearson's of coefficient of correlation. So this is the question. What's the formula? Karl Pearson's coefficient of correlation is equal to covariance between x and y divided by standard deviation of x into standard deviation of y. Okay. Here, check this question. The covariance between x and y is given in the question, which is 488. Right? Covariance between x and y is given in the question 488. So the numerator is available. Okay. Now, the denominator, it consists of two items, standard deviation of x and standard deviation of y. Okay. See, in this question, standard deviation is not given. In the question, variance of x and y are given. Variance of x and variance of y are given. Okay. If variance is given, to find standard deviation, use this formula. To get standard deviation, take a root of variance. Okay. If variance is given, to get a standard deviation, just take the root of variance. Okay. Here, the root of variance of first one, that means variance of x is given as 824. Isn't it? So, to get a standard deviation of x, take the root of 824. And it is 28.71. This is the standard deviation of x. Alright, similarly, the variance of y is given as 325. Isn't it? So, to get the standard deviation of y, take the root of that variance. That means standard deviation of y is equal to root of 325 and it is 18.03. So now we got standard deviation of x and standard deviation of y. So in order to get a standard deviation from variance, take the root value of variance, then you will get standard deviation. Okay, you have to remember this because this may be required in certain other places also. Now we are applying the values in the formula. Covariance between x and y, which is given in the question. Covariance between x and y is given in the question, 488. So 488 divided by standard deviation of x, which we found out here, 28.71, into standard deviation of y, which is also found out here, 18.03. Okay, then 488 divided by, multiply these two values and we get 517.64. Divide this value and that is the value of Carl Pearson's coefficient of correlation, and you know that the value of correlation is in between positive 1 and negative 1. Here it is in between positive 1 and negative 1. So it is a positive correlation also. Sign is positive, so it is a positive correlation. Okay.